Okay, so this is the second step in the Gantenbein winery definition. Previously in the first step, or step 00 that you already watched, we went ahead and took the 4-point surface, divided it horizontally and vertically to create a stacked set of points. But remember, to create the running bound, we made those twice as dense in the horizontal position. Now what we need to do is to create, and here's my next paragraph, we want to go ahead and in our little definition is to generate the running bound pattern. And to do that, we're going to go ahead and separate the list into an every other line using a series and a tree branch component. All right. Then what we're going to do is remove every other point with cull pattern, and then combine this data in a single list with merge. All right, so that's our easy step. All I've done so far is I've brought down the grid points, and all I did was coming out of this last component, I dropped in a point component, made it a wireless receiver by going to right-click Wire Display Hidden, grabbed the points into it, and drug it down below, and that's what I've got right here. All right, so you see that's coming from my P output of my divide distance down into that component. Now, first thing we need to do is we want to use that tree branch. So you can go find that underneath our math, sets, tree, and tree branch partway down. And let's give ourselves some space because we got to do a couple things before that. Now, if I run that in directly into there, we're going to have a little bit of an issue, and that's only because the branch structure is so long. You don't have to do this, I'm just going to show you in a panel tool, that you'll see that in the top paragraph here, the branch structure is 00000, and then the next one 00001 or 00030, 00040. It's only counting in that second to last numeric position. Okay, we don't need all this information before or that 0 after. They're really not doing anything. The only thing that's changing is that fourth position. So to eliminate all that, we're going to simplify it. Just simply right-click on the point component, the grid points, and set to simplify. And you'll see now all the data gets simplified to the kind of least common denominator type setting, where only the fourth digit was maintained, and we only have to deal with one branch structure, just 0. So now what I can do is say, all right, this is my tree that I want to sort through, and I want a very particular branch. In this case, branches are columns. So if I go in there and say I want the first one, which is the 0 column, wire that in, you'll see that what I get is the whole row of points on the very left side, the whole column, of points on the very left side there. All right. And now what I want to do is I want to pull out every other and do that whole delete every other one. So instead of me manually going in here and saying 0, 2, 4, 6, 8, we're going to go ahead and do a series. So we're going to go underneath sets, sequence, and series. All right, so we're going to start counting. The S input is 0. We're going to start counting at 0. In this case, we're going to count not by 1, but by 2. So the N input should be a value of 2. So we count every other. And the C is how far we want to count for, how long we want to count for. Okay, I need to know how many of these columns exist. To do that, all we have to do is figure out how many are existing in here. So we go 0 all the way down to this, the very last location seems to be 57, 58, 60, 61, 62, 63. There are 63 values, and because we started counting at 0, that means there are 64 sets of lists in here. I could show you. It's going to take some. There we go. Let's see if I can get it. There we go. 63 sets, which means we have 64 lists. Okay. Basically, it is the length of this line divided by the distance tells us the number of points. So if I go here, took the length of the line divided, if I count the number of points that are in here, this would tell me how many points. There are 63 index numbers, which means there are 64. Easiest way to do that is to count the number of items coming out of this divide distance. Count the number of points. That's easy. First of all, let's bring it down below. We know these are points, so there we go. We're going to bring this in, and we're just going to call these our base YZ plane points. I know it's a long title, but that's okay. Wire display, set it for hidden, and bring this down below. All right. There. Now I want to count the number of items. To do that, go to Sets, List, and List Length. The list length will measure the list of items, or the number of items in a particular list. If I hover over this L output, I get 64. Go ahead and wire that in. But I want to count, because I'm counting every other, I need half that amount. So I'm going to right click, do expression, and set this for x divided by 2. Let me move over so you can see it. Expression, and we'll set this for x divided by 2. There we go. So now it's going to count 32 times. So if I drop a panel tool coming out of my series, you'll see I'm actually counting 0, 2, 4, 6, 8, all the way up to 62. Okay? There are only 62 index numbers, which is perfect. I want to drop that into my P input. And now you'll see I'm getting every other column of points right there. Perfect. I want to do the same thing, but for the even or the odd numbers. I did it for the even. See, these are all the evens, 0, 2, 4, 6. I need to do the same thing, but for the odd. Let's make life simple. Let's start to group some of this stuff. So this stuff can all, let's just do this. Pull this over. And this is all about there. So we can kind of group all this stuff together. We need to reproduce this whole thing. So we need another series. So go to Sets, Sequence, Series. Okay. This time we want to start counting it not at 0 but at 1. So let's drop in a panel tool with a value of 1 in it. Tell it to start counting at 1. Again, we want to count by 2s. So I'm going to just copy paste and change this to a value of 2. And we want to do the same thing. Measure the length, divide by 2. I could just copy this. I could just wire this one down here if I wanted. But let's just copy paste it, make it part of its own group. Wire this in there. And again, right click, expression. Let me move over so you can see it. Right click, expression, x divided by 2. There we go. Now if I look at this, it's going to start counting at 1, 1, 3, 5, 7, all the way up to the very last one, which is 63. We had 63 list sets, 63 columns of points. There we go. We concluded them all. Great. We're going to do the same thing with the tree branch, but we're going to use the same data. We're using the same grid points to sort through, but we're going to use this new series in there. So now we have all the even columns in one branch, all the odd columns in the second branch. Perfect. You could actually even include this, add to that group there. That's all part of that group. And we'll group all this together. Perfect. Just like that. I'm going to rewrite, these are my even columns. And these are my odd columns. Perfect. There we go. Okay, so now that we've got those branches separated, we need to call with a pattern. We need 2 different patterns. So let's go to Sets, Sequence, and Call Pattern. Okay, if the pattern we want to call or the list we want to call from are all the branch info, like so. And we want to go ahead and create a pattern that is true, false. To do that, you can either write true, false, or you can hit 1, enter 0. Now, because we're giving it 2 different entries, we need to make this multi-line data. Right click, create a multi-line. So each of those items gets put in its own index line. 0 or 1, then 0. True, then false. And it'll just repeat that pattern for us. So we'll run that into the pattern. And now you'll see we get every other point of every other column. Perfect. Now I want to copy and paste this operation, but I want to reverse the pattern so it is false, true. 0, enter 1. Don't hit enter, don't hit spacebar, don't do anything. 0, 1, and run the branch into the new list. And there we go. If I go and turn off my old data, right click, preview off. Now you see we get the every other operation. So we get every other point, which is our running bond pattern. Great, that's what we're looking for. Now what we want to do is go in here and we want to merge these 2 things together. To do that, go to Sets, Tree, and Merge. Just run one into D1, the other into D2. When D3 pops up, you can leave it, or I like to clean it up and just eliminate that. And now you'll see what we get are all the lists of data, all the columns in order. So here's the 0 list, the 1 list. Notice the odds and the evens are now mixed back together because they had the same data structure. It assumed they were the same info, so it went 0, then 1, then 2, then 3, and so forth and so forth. Now we have all of our info into one component. Again, this should be repeat for you because this is, again, the call pattern operation using the branch, picking out every other column and then every other point in every other column, and then merging all that back together. Go ahead and use this, annotate this. You don't have to annotate all 4 of these panels because they're duplicating. You could simply put a panel tool in between these panels, say right here. Let me just give myself a little room. And you could use this panel to talk about what's happening in both of these simultaneously because they're technically the same operation, they're just using different call patterns. Here, these are technically the same operation, they're just using starting with the odd numbers versus the even. So you can feel free to discuss these using a shared panel, if you will, in between them. Perfect. Next, we'll go ahead and use the actual image sampler to start creating and rotating the individual brick units within this panel.